Hey, this is the KIN-MATICS Center of Mathematics. This is a channel that we shall be fighting a lot of problems. Please subscribe on the channel and please don't forget to click on the notification button. There are many things still coming. Then we are going to look on this problem, evaluate the integral of the square root of tan of theta d theta. Please subscribe. Now, in the beginning, I want to first you're going to allow me let the square root of tan of theta be a certain letter like t. Wow. This will imply that t squared, by squaring both sides, t squared is now equal to tan of theta. And when you try to differentiate both sides, 2t, you shall get 2t dt will be equal to, when you differentiate tan of theta, you get sec squared theta, which sec squared theta is 1 plus tan squared of theta. Tan squared theta. But when you look on our tan theta is t. So this will be tan power 4. When you come here, I said sec squared is 1 plus tan squared theta. But when you come here, tan theta is t squared, meaning when you square both sides to get a tan squared, you'll find that t is now power 4 the theta. So by dividing both sides by 1 plus t power 4, you'll find yourself that the theta is now going to be equal to 2t dt over 1 plus t power 4. Wow, this is now the theta. So there is no time. I'm just going to substitute back to our integral. When you substitute back to our integral, I'm going to use I as the integral. You'll see that here. Now, in this position here, instead of writing square root of tan theta, I'm going to write a t. So this t is going to be multiplied by the d theta, which d theta is this. So, meaning I'll be having 2t squared after multiplying the t. 2t squared over 1 plus t power 4. Wow. We go on. I'm going to put out this constant. However, I don't need to put it out. I just want to write it in this way. I'm going to divide throughout by t squared. I'm dividing t squared throughout. When you divide t squared here, you shall get 2. Let me put the t out. 1 over t squared, you shall get 1 over t squared. And the t power 4 divided by t squared, you get t squared. And this one will be 1 over t squared. Okay, I'm still going on. In this, I'm going to introduce something. This integral here still, it can be written as 1 minus t squared. 1 minus 1 over t squared. However, this was not there. So since I have introduced this, so I must get aware of removing it. Actually, let me write it plus and 1 minus 1 over t squared. This identity I have just introduced of 1 over t squared has now gone because it cancels with this one here in this bracket. So, and you remain with 1 plus 1 here, which is at 2. So it will be balancing the equation. The dt is still there over t squared plus 1 over t squared. Okay, we go on. Now our integral is going to be, I'm separating the denominator. 1 plus 1 over t squared. It will be a plus. When you separate it, everything will be like that. It is gonna take the share of the t, because it multiplies everything inside, over t squared plus 1 over t squared plus this integral here, the share integral, and the share the dt. Okay, this was gonna be 1 minus 1 over t squared over divided by t squared plus 1 over t squared. I'm still going on. Now I want to write the denominator in this way. Please, you should observe this step here. It is true right now. I did this because I can write now the denominator in terms of the numerator. Otherwise, I want to write the denominator in the way such that the numerator becomes the derivative of the denominator. This is it. 1 plus 1 over t squared can be written as 1 plus 1 over t. Seriously? It is 1 minus 1 over t. Well, having wrote a minus here, so I have to put a 2 there. Such that when you expand, let me try to expand. When you try to expand this stuff here, you shall be having t squared plus 2 times t squared plus 1 over t squared. So you can see that the t squared will be cancelling to get a 2 only. Okay, this is a minus, I'm sorry. So this must be minus t squared times 1 over t squared plus 1 over t squared. So we can see that we go back if we try to, because now the item that will be not part is this one here. So you just need to write a plus 2, because the t squared goes with and you remain with 2, which will be cancelling with this. So our equation, by writing the denominator in that way, we are correct. Okay, now plus, I'm going to write even the second integral as in the form 1 minus t over, I'm writing it in this form, and I'm trying to write it such that it becomes, I think that's okay. All these are correct. They are correct forms. Now when you can see that in the first integral, if you let this stuff here and you differentiate it, you end up having that. I'm saying you're going to let t minus 1 over t squared being equal to u. Everybody can see that when you differentiate the other side, you get 1 minus, wait a bit, this here is not squared, it is just a t, and when you differentiate it, you get a plus here, not a minus. 1 over t squared dt being equal to du. Wow. And still in the same way, I'm going to let now this one here, which is t plus 1 over t, I'm going to let it to be a certain letter like x. such that I differentiate both sides. Here when you differentiate t, you get 1, and when you try to differentiate 1 over t squared, you get a negative 1 over t squared. When you differentiate here 1 over t, you get a negative 1 over t squared dt being equal to dx. Now I'm substituting back to the integral such that our integral right now is going to be equal to, wow. Now instead of this, I'm going to write, instead of this numerator with its dt, I'm just going to write du. Everything in the numerator is now represented by du. Wow. And now I remember I said this one to be u. So in the denominator now I have u squared plus 2 plus this integral here. Also in the same case, for right now, all the numerator is now represented by dx. And remember here also down I said this is now my x. So I shall be having x squared minus 2. Wow. Okay, I'm going on strictly. Now we can see where we're going. I'm writing them in this way. Du over 2 plus u squared. When you look on this next one, actually this has an x squared minus 2. I want to write 2 the first. So I'm going to factorize out a negative such that this one becomes a minus du over 2 minus u squared. And when you try to integrate this, these are common identities. We actually know what happens when you integrate this. And the first integral we shall have, wait a bit, this was x, not u. This was x, not u. Okay, the first integral we shall be having 1 over root 2 tan arc. That is tan substitution. You integrate that by tan substitution. So we shall be having 1 over 2 tan arc over u over the square root of 2. And in the next integral, we shall be having a minus 1 over those. That's also a common identity. We integrate this using cosh. So we shall be having 1 over root 2. Not cosh, but tannish. This is tan arc. Here we use tan substitution. Here we use tannish substitution. It is a hyperbolic function. Tannish arc of what? Of the same thing, x over root of 2 plus the constant of integration. Now I'm substituting back the u. We said from here our u is that, and from here we said our x is that. So I'm substituting back now. We shall be getting, instead of u, I'm writing, and remember it is t minus 1 over t. So I'm going to try to use some speed and get the LCM, which will be t, such that it will be t squared minus 1 over t, which t is going to be here in front of that. And also here, it's going to be t squared plus 1 over t, which is the same as writing it there. But remember, we said in the beginning, we said let t, here we said let t be equal to the square root of tan theta. So instead of t, I'm now just going to write, instead of t, I'm going to write the square root of tan theta. But because of this square here, the square root will be going away such that we remain with tan theta. but here it will be fine to write the square root of tan theta. So it will be square root of tan theta times the square root of 2. They're all squares. They can go under the same bracket. This is also tan theta. Square root of tan theta here also, but they are all square roots. They have all square roots. They have the same degree. They can go in the same bracket. And we write it like that. Wow, finally we have accomplished the problem. One thing you can do right now is you can subscribe. Please go and subscribe on the channel. This is the only way you can please support my channel here. Subscribe on the channel. And thanks for watching. Thanks for watching.